So, hello, my name is Jerzy Nowiński, and today I will be talking about money. And to be precise, about how you can save your money while developing, while creating the application which are focused around the ML algorithms. Uh, First, about small introduction. As I mentioned, my name Jerzy Nowiński. I'm a head of development in ShareTheBoard. My previous experiences are like with telco, big data, data governance, and like finally machine learning and computer vision. But what is more important is the ShareTheBoard itself. And this is the application which is used to detect handwritten content in real time. And it might sound like yet another OCR, but it's not. As you can see here, we are taking the video stream. We are picking from the video stream selected frames. Then we analyze them in real time, detect what has been written then, like keeping the spatial structure of what has been written. So it's not like OCR. It's like, as you can see, it's like in the end, we have an image of the content. We can then overlay it, for example, on the source video to have this augmented reality experience. And what is interesting, this our application was like driven by AI even before the current LLM hype. And how it's connected to the my speech, because I will be talking about the things which are like, which are the way that you are spending your money on while building ML application, how you can optimize it, how you can even don't pay at all for the for running it on production, because it's also possible. And it will be based on our experiences. So it will not be like some random theoretical talk. No, it's all based, the story is all around this application. And you may think, okay, I'm not doing the computer vision stuff. If should I just right now just leave the room? I hope not. There are, I think, two main reasons. First, even if you are not into the computer vision stuff, you may find it just interesting. It's like just another way how machine learning can work, what you can do with these technologies. And this one aspect. The second one, a lot of the stuff that I will be presenting you is like, it can be applied in not only the context of computer vision, but to be honest, like any context. So this is like just a global, in some cases, global universal informations. Okay, so I will start with the question, why creativity sucks? Anyone? Exactly. The answer was, is expensive. It is. And I'll show you on our example. So our like main goal, as you see on this video, is to take a single frame and to like more or less get these kind of results. So get the content, only the content pick up from the frame, even if, for example, is abstracted, even if someone is between the camera and, for example, the whiteboard or the flip chart that we have in our room. And then we want our application to be able to run it inside the web browser. So this, especially the last part, make it quite tricky, because like only detecting the content, it's not that like, it's not something, wow, I'll be not sharing this with you, but doing it in web browser. So we started to idea that we'll build our model, machine learning model, convolutional neural network. We selected, like, created architecture for it. We gathered the training data. We train our model, optimize it. We test it on the reference images. It was really working quite okay, quite well. We then move it to our web application, run it with real data, and like it was a disaster. It's like, if you, it was like detecting the content, but the performance, like all the UI of the web browser just crashed completely. And we're okay, what to do with it? Like, let's start digging into the problem. We created our own library to execute the models inside the web browser. We tested on our development machines. It was working quite okay, but then we picked up reference laptops because our solution is mostly targeted for the corporation which have some standard laptops or in the area of education. So we have the spec of the device. Unfortunately, this device didn't have any GPU, only integrated card, and we failed once again. So it was also just running too slow. And there was a moment, the point in which, okay, probably we will be dropping the whole project, the whole work around it, 1 year of work for a startup, which is not extremely huge. It's a lot. Thankfully, in the end, we managed to use the much smaller model. We add some additional model, we add some magic, we add some tricks from the standard computer vision algorithms, and it works. It's working right now. It's okay, I would say. But it was a point in which it was not that simple, in which we were thinking, okay, wow, we just it didn't go well. What was the issue? It's something quite interesting, to be honest, that when you use standard library to execute something in the web browser, like TensorFlow.js or Onyx, it's working okay if you have low, for the computer vision, if you have images in low res, then it's fine. But if you are using full HD images, it tends to block the GPU. So the web browser itself has no space to render itself like the screen. So we build up our own library based on shader applications in GLSL that enable us to execute to split the model into the smaller batches, more or less one batch was one layer of the network, or not exactly, but almost. And then we execute this part of the neural network, force the execution, and then it's giving the space to the web browser interface to render itself on the GPU. So yeah, it's working. So it was great. That if you think about you're building new application or you're in the company, it's showing this example that you can waste a lot of money, the money you spend while you are training your model, but as well the time of developers. The results may be far from perfect. It may be that, okay, you have an idea, it should be fine, but you are spending a lot of time to validate this idea. And then when you finally get to the point and it's not what I expected it would be. So this is another aspect. And then there is a chance that you can just use some off-shelf solution, or even during the time that you will be creating your great system, someone will, I don't know, release an open source model which will be doing exactly the same. So these are the cons, but maybe you should do it. Why? If it gives you a strategic advantage, like it gave us in this particular case, because this is the core of our business, this engine, content detection engine, and there is nothing there on the market. So then it's okay. And please remember that time is money, and it's not only that you need to pay. It will be if you are developers, it will be your time that your employee would need to pay for your time. It will be as well the time that your product, your idea is not on the market. You may just miss your point if you spend too much time in the development phase. But what can you do with it? Sometimes what can you do with it? So first thing is another challenge that we have. So when we are detecting the content, we usually do it with for example, we have a flip chart in here, and we want to only focus on this area, not to analyze whole frame because it will take a lot of resources. So then we would like to detect it. The user can manually adjust it, of course, but we would like to support them. So it's not critical, but important feature. And as there is nothing on the market which help me to detect exactly the position of the area of the whiteboard or piece of paper, then there are already networks which will help you to detect objects. And we just thought, okay, the corners of the whiteboards or piece of papers are the objects, and we can just detect them. So there is already like models for it, like YOLO, and this is something that you may also think that if there is, for example, open source model on the market, it may not exactly fit into your problem, but you can reshape the problem. You can think about how to think differently about the problem, then adjust it to the model, train it with the data, so you still need to train it, and you will have some solution much quicker. But you can go even further and look even more. And sometimes you are just facing, this is a step in your algorithm, one of the things that you will be doing in a chain of the calculations. You can use something which is already there on the market. So, for example, in our case, in some cases, we are just needed to detect the silhouette of the person, like if you're looking at me, and there's a body pics which is doing it just fine, and you can just pick it up. We are right now working on the feature which enhance our capabilities in other areas about the audio transcription. And you can just pick up the whisper. It's like laying there, created by OpenAI, and you can just run it on your infrastructure, and it will be fine. You don't need to spend a minute on it. Only maybe, and this is something that you should be checking, how big the model is you should use. And usually it's like the best use. The smaller model you use, the less money you will spend on running it. If you check how just downgrade from the big model into the smaller, and check which one, or the other way around, which one still is okay for you, is providing you the good results. Something to consider, like if you are really on the budget, usually the people, okay, I have a model, I need to run it on my on some GPU. But in some cases, you can, if your scale is low and you don't require big model, you can run it on the CPU. For example, you want to check something, you want to simply quickly deploy into something on the in test environment. And for example, we are sometimes using run one of the models on Lambdas. As well, we are doing some additional stuff, which I will be taking later on, which also there is a decision. Should you run it on GPU or CPU? But it will be a different story. And when using infrastructure, this is very common stuff, is that anything that you will be doing, if you're running your backend or backend views for the ML, it will be the same. Look on what exactly you need. If you want to validate your idea quickly, probably going with public cloud provider and some dedicated service, yeah, it will be fast, but expensive. If you know, okay, you have some space to manage the infrastructure, use on-demand resources. If your service doesn't require huge stability or can work offline in a way, you can, for example, pick up spot instances, which are even cheaper. Cons of it is I don't know, it's our experience in terms of AWS. In past, we've been using it, for example, for our dev environments, but right now I see that it's restarting, rebooting more often, so the SLA is worse, so we migrated from it completely, but it's still an option. And finally, you can go not with the public cloud providers, like the big one, like the big for five, all the names, but select something which is more local to you. For example, I know I'm from Poland. In Poland, there are some mobile network providers have their own warehouses with infrastructure, which is usually much cheaper. You need to manage it by yourself. It needs to be for the longer rental. So you already know the scale of your business, of your application. You know it will be running for a long time, but it is a good option. It's much cheaper. And finally, you can, for training your model, purchase the GPU and place it in your office, which may seem like a strange idea. But for example, we are using European Union funds. And in these funds, it's more difficult to get money for infrastructure. It's much easier for the purchases. And we are just buying the GPUs and use it to train our models because it's just cheaper. Question is, can you predict the future? if you can, what will be happening with your solution? You can then select the right path because it's mostly depends on what will be your scale, yeah, how many like nodes you need, how much GPU power. It's of course difficult to predict the future. If you could, you can just play roulette, win, and it will be yeah, you won. But in some cases you can. Like for example, in our cases, we know that we just like acquired the next funding from you, and we know that we will have a stable funding for the next 3 years. So in a way, we could predict a little bit the future. Next up, moving. Do I hate OpenAI? It will be hard for you to answer this question because these are my feelings, but no, I don't. But I know that the OpenAI have and any SaaS provider providing you access to LLMs have some pros and cons. But let's go to our next challenge. So we detected the content. We have this nice frame, apply it with this, augmented with our content, so great. And we would like to change it into the format that you can easily edit and which will keep the structure of the content. So for example, this nice UML. But how to do it? So the first thought that you may have is like, go with the OCR. There are so many of them, it's just like the open door, just go through them. Unfortunately, it's kind of crappy solution because if the people are working on the whiteboards, the content they create, it's like kind of random. They place it some writing in various spots of the, for example, whiteboards, this working space, using, for example, the native language, but then as well adding some words in English or some strange abbreviation. And from our experiments, it was like we received the accuracy of around 40-50%, so really horrible. And it's difficult like to make sense, like even if you have words, they are not like keeping the structure of what really has been written, because on the whiteboard while you are walking, it's not only the words which counts, also the position of the words, the relation between them. So we are thinking, okay, what to do with this problem, because it will really enhance our product. And we checked, let's go with the VLMs. I don't know if you try it, if you know it. It's like 1 year ago, the big LLMs were in fact became under the hood the VLM, so visual language models. So right now you can provide to the, for example, GTP 4.0, as well, you recently, like from the Llama 3.2, it's also there, this functionality. There you can insert like into the prompt an image and the text prompt and have the result in the text, which is really nice. What's more, it's like these capabilities of understand what is on the image, what is actually happening. It's really like not always, but often very, very good. It's not only like able to, to know what's in the image, but interpret the data. So you can use it like in our solution. I was just thinking we have some training data taken from classes and just using it to understand what was happening inside the class, to understand exactly what was, because I saw the board and like, I don't get it. And it was working quite fine. But so where are the cons? There are cons and there are a few of them. So first one, which really annoys me, is, and this will be where you using any LLMs, that your application, you tune it up, you, for example, do all the stuff that you wanted to do, and it's working great. And then time passes, and it starts to works like not so good. It's like the service is degrading, and like, okay. And it's due to the fact that, for example, OpenAI IP providers like changing the models, like updating them. It's not only that you go from 3.5 to 4 and that's all. No, they're upgrading the models, so it change. And when it changes and you are used to some kind of output, it will affect you. And in a way, it's not like it's working, not working. Then it's easy to detect. It's just like it's like working worse and worse. And you need to optimize it. And you will not be doing it constantly because it will consume a lot of money and time. And time is money. But from time to time, so something really, really tricky. Next thing is that there are limitations, and for example, on Azure, they are really strict about how many tokens you can use. And there are not so many, like, to be honest. And even if your business is valid, you can use them. You have money. You're bringing stashes of money to, for example, Microsoft on Azure. They will say, okay, sorry, you have a limit of tokens. You can go above that. So maybe there are ways like to overcome it, but it's for sure not easy. I don't know them. Next one is the stability of the solution. This is like, for example, if we have an issue with our VLM, it's like I'm not looking to our infrastructure. I'm checking. We have a separate like health check on OpenAI and saying, okay, OpenAI service is degrading, and it's okay. So this is something which really surprised me. And as well, it depends, like the time delay can vary based on how many people are trying to access the API. So your model one time, it's like working really, really fast, and then the responses are slow. And if you are providing service to the client is not thinking, okay, oh, he's using the Open API. I understand it. I need to wait longer. It's just think, okay, the solution is a crap. And finally, the price tag, which is like, this solution could be expensive, but I will be getting back to the pricing later on. How you can enhance the solution? You can use the fine-tuning or a RAG. There are some talks about it. To be honest, in our case, like in terms of like visual data analysis, it's not really a thing. So mostly what we are focusing is prompt engineering and the validation, like post-processing, like we have an output and we can somehow validate it, improve it analytically. And this is, in fact, quite a cheap and easy way. Like fine-tuning thing take a long time. Like RAG, you need to have it, you need to add it to your system. And prompt engineering really doesn't take you so much time. So this is just cheap and easy. And if you are like going somewhere, I would start with this one. And for example, thanks to it, based on like this, we have some image based on some this video. As you can see, we are able to turn these kind of scribes on the whiteboard into really nice charts that you can, for example, modify. Okay. The last stuff, not really related to cost, but if you are using this kind of solution, there is one additional cons that if you can build it within 5 minutes, then probably anyone else can build it as well. So you are, okay, I have a great idea, I will build it, you implement it, 5-10 minutes, you just deploy it, it's working on production, you spend a lot of time like on getting the customers, and then someone else is just copying your business within 1 hour and taking your clients, and it's sad then, but it's something that you should consider as well. It should not block you from using this kind of solution, but you need to keep it in your head. So the last thing, and I believe it's very important that if you are using any like a paid API, any SaaS, look into what is the pricing, how the pricing for the model looks like. And for example, in the case of these visual capabilities, it's kind of tricky. It's not that simple. So there are, like in case of Open AI, there are like two main, I would say, objects, like two ways how you work with the API. One is you analyze images in low res. Second one is in the high res. Interesting is that low res is really, really cheap. Like if you want to analyze the image in low res, it's 85 tokens on the input. For me, cheap. With the high resolution, you can think, okay, like probably it will be linear. If I have like 4K image, it will cost something. If I had smaller image, it will be like less, but it's not. It's how OpenAI works. It's like it takes the patches out of the image, and if you analyzing 500 of 500 pixels, or if it was 512, then it's count as a one single patch. if you analyze the image in this size, or the model automatically reduce the size of the image, then it's like this low resolution is quite cheap. If you want to go into high resolution mode, then it's calculate how many patches you have. And sometimes it could be that you are analyzing the image, which is just slightly above some threshold, really like few pixels, and you are paying like 3-4 times more for a single query. So this is something which is like good to like think, do I really, what kind of resolution will be perfect for me if I can fit into these constraints? And yeah, that's quite interesting. As well, think about the number of requests you are making to the API. Because, okay, it's easy to build. In our case, it will be like easy to build system, which is like calling the API all the time. And then we'll get bankrupt, get over the limit of tokens, get bankrupt. It will be like disaster. But what we can do, we can use other algorithms which help to decrease the number of calls. We can, for example, make some calls maybe with lower resolution and only selected calls with high resolution, which is much more expensive. So this is something that you should like watching on this table of their like pricing of your API provider and think, what should I do? And if you want to read more, there would be article like released on MLCon. This is by DevMeow released magazine, so the organizer of the conference, which is called like Beyond Object Recognition, written by me, that you can read. It will be in the next issue, next issue of the magazine issue. And going even further, because we're talking about the optimizing the cost of running ML. But do you want to pay for running the machine learning-based application on production? I hate paying for anything, so I don't want to pay. So, as you know, we have this challenge. We want to detect the content in real time. Yeah, great. And we have an option. We could run it on the server side, where we can run large models, which are very accurate. We have full scalability. We can add additional nodes if needed. That's nice. And we can use any technologies that we want. Or we can go front end. Front end, you are trying to run the model on the user equipment, which could be really quite not good. So they could have like only some integrated graphic cards, or they can as well run a lot of processes. So you want to run something on the computer of your client, and he's saying, okay, I have a great gaming PC, but it's working slow. But you are checking, and he's like digging bitcoins in the background, and it's like killing their whole hardware. And also, you can use only native apps, so like to run the models like something written, I don't know, in the C++. So we decided to go with the front end, of course. And why? Because if you are analyzing the video, you have this image. And if you are, as I mentioned, we are analyzing it in full HD. And even transferring the data, because if you like, for example, using the Zoom connection, you are transferring, you can transfer the video stream in full HD. But if your connection gets degraded, then you are starting to compress the video stream. And in our case, to be able to detect this content, it's really like you need possibly as good as possible the image quality. So we would need to send the full HD frames, not compressed, not so much compressed, to the server, and it will use the internet connection, and as well it will cost, because if you are receiving and doing anything with these like large images, it will also cost of running of your backend infrastructure. The price of your backend infrastructure will go up. But what's more, you will be running inferences like in here, real-time scenario, one after another, after another, after another. And it will be just extremely, extremely expensive. So why not run it in the distributed architecture? Why not pass this cost to your clients, your customers? and pay nothing for it. And you are afraid of like building a native application because they are like they have cons. You can go right now and build application as a web application. You have their technologies like WebAssembly, which allows you to run inside the web browser the C++ code. It's not that efficient as the native code, but it's better than like standard JavaScript. You can use WebGL, like recently released Web GPU, to gain access to your GPU from the perspective of the web browser. And the hardware is getting better and better. And it's also, if you read some news, if you're checking that, for example, Apple is adding the better chipset to networks or then on the mobile phones, on the laptops, and all the hardware provider also looking in this direction. And it's showing that probably it will be in the future, like putting more of this calculation on the endpoint devices. It's really something that we observed that like 2 years ago, it was really hard. And right now, even Intel integrated cards like Iris is handling the neural networks much better than the previous UHD integrated graphic cards. What's more is something that I don't know if you're working with the clients, it is a big issue. It's the privacy. So imagine our solution, and would you want to use the application which is taking your images to some, I don't know, server somewhere? Like this is something like you will be, I don't know, going with the, something strange happen. Like you don't want any like random company to have your video of what you are doing in the front of the whiteboard. And in this case, all the calculation stays on the end user devices. So we are saying, okay, we are not we are not taking, we are not uploading any images, any video that you are taking. We don't care. We only take this content, if of course you want, and then we are storing it for you so you can use it, you can archive this data, anything. But it's not your images. So we don't care about any privacy issue. It's a lot. Next one, it's something which can be like resonate with you, like this technology is green. A little bit, it's not like completely green. I will tell you why in a second, but it is more green the standard solution because you are not for example, Equinix, which is like building these big warehouses for all the public cloud providers, will not manufacture another server to it into the warehouses. In our solution, we are using existing hardware, which is already there. The clients already have them. And it may resonate it with you, like because you are thinking about environment. It may as well resonate it with you because European Union easier for your company to get some additional investors, or like even in some reports to the European Union showing the direction. Next thing is I promise you talk about the CPU and GPU. When you are working and you are trying to run your model inside the web browser, you may think, okay, you should think, can I calculate inference using the CPU or GPU? Usually CPU is much safer. I told you this story before about us building the solution, so we'll not model is small enough, you can fit it into the CPU. That's great. Some problems solved. But now go even further in this road about not spending money on ML. And this is like when we started to build our application, you can imagine that we would like go straight into the machine learning based solution. But it's not true. Like we started with the classical computer vision engine to detect the content, which was only enhanced a little bit by the some machine learning, like small neural network. And it was working fine. At some point, we hit the wall with the glares that we couldn't overcome in an analytical manner, and we end up with machine learning. But we still have our classic computer vision solution, it's still running there. It's still for the people who doesn't have like dedicated graphic cards or maybe have not so good equipment that even after all the optimization, they are not able to run our neural network. And this is for like some thought, maybe it's not the good place because we are on the ML conferences. And right now I will tell you that maybe you should not always use the machine learning. But I'm seeing right now when talking with my friend, talking even with our team, that if you are focused so much that, okay, machine learning is only the tool, the one tool that I have. So if you have your only tool is a hammer, then every problem becomes a nail and you want to hit it even if it's not a nail. So please think that like machine learning is great, but for example, you will have often non-deterministic results. And sometimes it's okay, but often your clients, like the people using application, for example, want to have something that if I put some input, I have the same output. You can try to do something like this using the machine learning, but it's not always the case with LLMs. It's quite difficult because like big API providers, which are currently one of the cheapest way to run LLM, are not so, it's not always possible. And then you are using the GPU if you want to run something on your end, and GPUs are right now expensive. If you want to fine-tune your model, if you want to train your model, you need to gather the training data. And this is really complex task. You need to have good training data, not some crappy one. You need to select it. Sometimes in the case of computer vision, you need to like annotate it. Difficult process. Finally, the results are often you are going with these, the LLMs are perfect examples. You are going, in our case, it was VLM, and it was, wow, it's doing like wonderful job. It's great. And it's like, fine, but from time to time, your results are quite not so good. But you think, okay, 80% of time is fine, so I will be able to tune it up. It will be great. And then you learn that, in fact, going above this 80% is very, very difficult. So this final step, like a little bit of optimization, sometimes is just impossible. And with standard analytical algorithms, this optimization path is usually smoother. But saying all that, it's like when you see the problem, there are cases in which machine learning is just great, just wonderful. And for me, it's like a little bit about using NoSQL databases. So there are problems in which you know that you should use NoSQL database. But if you are like having some like system you want to design and you are, okay, I need to, I don't know, add Cassandra in there. It's usually not the best idea. Probably to start, you can start with the standard relational database. In this case, like maybe analytical solution. If it seems okay, this is something which is I'm not able to move forward, then go to ML, and it's perfectly fine. But yeah, often I see that even with the simple task, the people try to, okay, I will go full LM day one, even if I have to, I don't know, change some letters in a document. To sum up, think that when you are that there is the parameters that you want to optimize is both money and time. The money you spend while running the model, while training the model, and the time you are doing it. So sometimes it will be more efficient to use solution which will be more costly, but you will develop it much faster. So this is something you need to calculate, you need to think about it. Next one, what is your scale? Usually, the bigger the scale, you need to use the different approach. You need to really start thinking how much each inference costs you. If your scale is slow or your business is one in which it doesn't matter because you are taking so much money for your customer that it's still fine, then it's great. And think about the system, how you are building your system, because sometimes you can reduce the number of calls to your model and then pay less. Also, think if you can, for example, calculate something on client side, then transfer the cost of running your model onto your customers, and even if you don't need the model at all. So in sum up, with the ML, it's like, it's okay, it's easy to build like wonderful application, but if you, your goal is not to create something which is like just working, it needs to be profitable, it needs to resonate with the business case you have. Yeah, and that's all. Uh, my data, you can any questions or catch me after the call. Please don't forget to vote. I would love feedback from your side. And right now, are there any questions from the room? Huh? Oh. No, okay. So the model was the question was if since we are running the model on the client side, is there a way for client to see what is happening there inside the model? Uh, yeah. Yeah, yeah. So there was like I refine it like the measure how much the model is affecting the performance of their PC. Sure, they can like to your power like level is going all the processors like the cooling system of the laptop is going to measure it sometimes only to listen the laptop, but since it's used, the scenario is for the presentation, like we are running the presentation, and the laptop probably is standing somewhere in the corner. It's cool, but it's like this is one of the aspects that we are optimizing. It's not only the time from the person is adding the new stroke on the whiteboard and the time that we need to detect it, but as well this consumption of memory and power and the GPU usage, because it really can go. This it is happening. This is one of the things we are working on, but at the same time, the memory consumption. And for example, we have our solution can be run in the web browser, but as well as an application, as a content camera application. And in there, like we are optimizing it, but due to the use of our technologies, we are kindly eating all the memory. And if we go above some threshold, like 90 something percent, then the content detection time and the performance of the laptop is going down. And then users are saying, okay, I'm using your solution, and then I cannot work with my laptop and have a Zoom call. So yes, it is happening. It is something that you should look and want to run your like application on a calculator, then for sure the calculator will die. So you need to have some minimal requirements regarding the hardware and telling the customer so they will be aware. And of course, optimize as much as you could. Okay, and the next question. Image. When it's like set up, for example, high resolution, the API will downsize your image so it will fit into the box, which is like 7 to 6 on 2K from what I remember, on 156, no, 2K, like kind of patch. So you have 4K image, which have some different proportion can have, and then it will fit into this box that I describe, and then it will calculate how many patches it requires to run it. and add some additional overhead. So it's like calculating the price. It's taking how many patches, then adding some small price onto the total value. And this is why you should like little bit by few pixels, and you are already saving like twice the cost of your one call. So it's depend like sometimes you really require like high resolution because the model will the higher resolution you have, the more details, and you want, if you, for example, in your scenario, you want to have detail analysis of the scene of what is on the image, then you, unfortunately, you need to go, you have as high resolution as you need. But sometimes, for example, even the lower resolution will be fine. So you are looking at the image, then yeah, why pay more if you don't need to? Mhm. Okay, I see no questions online. So anyone else? Yes. Hmm. Hmm. Uh, yes. Yes, so the question was, is it like our like this library that we use to split our model? Is it open source or not? Like, unfortunately, it is not. We are keeping it a secret. Is as well like adjusted to our model. So it's not the library, open library that you can use to run anything. It's like specially adapted to our model. And this is like one of the core technology that we are probably not sharing in a long time. With our like model, our network to detect, so our engine was like created from the scratch. If you are using the VLM, so like GTP, we are just to transcribe the data, we're just using the GTP without any fine tuning and just work with the prompt and with the results. But our core engine was created. So this is like about this creativity. In our case, it's like it's working. It's core of our product, so it's fine. It's okay. Yes. Hmm. Yeah. Yes. Yes. Yeah, we are in fact doing it. So we just measure the performance in the most like straightforward way. So we measure how much time it takes for one inference to calculate. And if we like beyond like the threshold that we selected, we are then showing the pop-up to the users. Okay, hi, we detect that it's not working so fast. Change the engine and use these like classical computer vision solution, which is working really well even on old computers. Of course, if you run it on some very old and poor laptop, it will not work. But this is not our case. Like if in terms of like standard laptop, the legacy solution will be fine, and then this new one they will just receive information. You need to change the engine. Yeah, and to be honest, like in many cases, you are blocked from the information what equipment your users are using. For example, recently we are looking on the mobile phones. In the mobile phones, it's even more difficult. And right now, we are only like supporting for the single like images that you are making a photo and then analyze, but you have no information about what type of mobile phone was used. So it is all like anonymized, so which is very hard to detect what users are using for. And as well, if you are, for example, trying to run model on iPhone, it's yeah, it's really crappy. So it's like if you go above some memory threshold, they just think, okay, we are clearing this app, and you just receive a huge error. It's nothing that you can do. Like we are trying to optimize it right now. So on the Android devices, we are able to run our model quite nicely, but with the iPhones, okay, great. So thank you. Last question. Okay, so the question is, since we are running on the clients, are we completely independent from the OpenAI? So we are running it on the client, the content detection engine. So this stuff that you see the image and the content is appearing over, for example, the person. It's also sent via our backend to other participants so they can also see it. And for it, we are independent, but we are using the transcription system, and for this one, we use OpenAI. But this is a little bit asynchronous. So for example, right now, it's used that the client can have for any given moment, can check and transcribe this information. Or when it's stored on the backend, we will add some feature that at the end of the session, it will create like some kind of summary from what was happening. But it's asynchronous, so if we will not receive any answer, we can just leave and provide a user with like a default message. So we are using it, but we are not fully depend on it. So if even if they are crashing, then yeah, whatever. Mhm. Okay. Sure. Okay, so the question is it like this solution embedded into the Zoom, or is it like independent application? So let me answer. It's a complex question because yes and no and yes. So first, it's like when we run it inside the web browser, it's an independent application that you can use, for example, during your Zoom call by just sharing the screen and then providing your user like a link so they could see only the content, which in most cases, like these augmented images with the video, it's look cool, but to be honest, when the people are using it, they want to have just like what has been written on the table in the separate tab and see normal video without any writing. Sometimes they want it, sometimes not. So then you can share the screen and using the web application. We also created the virtual camera solution, which you just run the application, and on Windows, it's provides you with the virtual camera that you can use anywhere, like in Zoom, MS Teams, etc. Just as an input, and it will be in there. There is all this content. You can apply the content on you, so have this option or not. You have the links that you can share to users, and it's like working in a background, so you don't see it at all. And the third option is that we created the Zoom app, which like right now help you. You need to have this web application running in the background, but is providing users with all this content inside the Zoom itself. I don't know if you know, you can write an application on Zoom, on MS Teams as well, and run it in the background. If you ever think about or have thoughts about writing application for Zoom, I advise you not to do it. Like, sorry, their environment, marketplace is like so horrible. They should not be doing it. Like we went this way, spent a lot of time. It's just horrible. I'm sorry, guys from Zoom. I know that you are trying, but no, it's just like even the information you get from the support is like contradicting itself. You don't have documentation, because you have documentation, but it's all wrong. Like, okay, so thank you and wish you a good rest of the conference.